Now let's see what are the various things required in order to build this microprogram control unit. So just now I told you that we need something called as micro instruction register. Micro instruction register. It is just like the normal instruction register. In normal instruction register, what we have is normal instruction, and in the micro instruction register we have a micro instruction. And this micro instruction is going to be divided into three parts. First part is going to be for condition checking, or these three parts can be anywhere. Here in this example I'm just using the first part for condition checking. Okay, and this part, it can be used for micro operation, which means control signals will be generated here. Control signals. Okay, and this part is going to be useful for next address, right? So how is it useful, or how are we going to use it is, if this is the micro instruction register, if this holds the actual instruction that we are executing now at present, there should be a program counter which should say what is the next instruction that has to be executed in the micro instruction sequence, right? So along with it, apart from it, we will have instruction register and program counter. What will these contain? This will contain the normal instruction and the pointer to the next normal instruction that has to be executed. Once you have fetched this normal instruction, or to fetch this normal instruction and decode this and execute it, we are going to use all this. Got it? Okay. Now this one should also have, our control unit should also now have micro program counter. Okay. And now what should this micro program counter do is, it should always show what is the next instruction that has to be executed. Assume that you are in the fetching phase. Now in fetching phase, we might have many operations that have to be done one after the other, right? Let us say 3 or 4. Now this entire program, this entire micro program or micro subroutine, micro operations, they all have to be performed one after the other. If the first one's address is 100, then after 100 is executed, 101 has to be executed. After that 102 has to be executed. Let us say this is fetching. Fetching is over. Then maybe the decoding, this is the logic for decoding. Decoding may be at 200. Therefore you might have to load into this 200. So the next address need not be always the sequential address in order. It might be some other address as well. So this particular part is going to say what is the next address that has to be loaded into this in order to execute, or in order to go to that particular part. Okay, so these two are connected. But then, do you want to load it, or do you want to simply increment it? Increment it to the next from 100 you want to go to 101, or from 101 you have to go to 200. That will be decided by the condition. Got it? So what is the condition is, we sometimes want to check various flags. Let us say I have 4 flags or 3 flags. Okay, now these 3 flags will be connected to the multiplexer, right, like this. And the output of the multiplexer depends on what this flag is. One may be carry, other may be sign, other may be overflow flag. Just for example I am taking this. Now in order to choose one of these, let us say this is a 4x1 multiplexer, right, and this is 1. So this means if it is 0 0, the output of this multiplexer will be whatever is present in this particular overflow flag. If it is 0 1, the output of the multiplexer will be whatever is present in the sign flag. If it is 1 0, whatever is present in the carry. And I am just leaving this to be 1. It is always it is always connected to 1, which means if it is 1 1, it will always be 1. Okay, now this multiplexer is going to have select lines, right? Those select lines I am going to get it from here. From this part I am going to get the select lines. Okay, let's say S1, S0. Okay, now are you understanding this? Now what I'll try to do is I'll connect it to this load. See, I'm trying to make this concept as simple as possible, taking my own examples and trying to clarify it. Okay, so try to understand this one. Textbooks will contain some complex examples and complex explanation. Try to follow this. If you can understand it, this topic is very simple and you can just see the question and answer the question. It is very simple concept. Okay, so try to focus here. Now understand this one. Assume that we have to load, let us say at this point, it is better that we have one more input as well. Okay, one more bit, unconditional. Okay, I think this is enough. So whenever there is some condition here, let's say I'll indicate whether it is you have to use this condition or not. So whenever this is 0, I'll not use it. Whenever this is 1, I'll use it. Somehow we have to, sometimes you might have to use it, or sometimes you need not use it, right? Or I need one more input here, I have to use it. Okay, see this. So what I mean to say is, whenever you are executing an instruction, if this particular load is enabled, then whatever is present here will be loaded into this. Let us say the instruction is in such a way that you want to jump to this particular address after executing this particular instruction, micro instruction. You want to the micro instruction which is present at this address only if one of the conditions is met. How can you put it there? Let us say it is a kind of instruction which will check or carry flag, and if carry flag is 1, then only I want to jump into this. Then in the condition flag you have to say 1 0. If you say 1 0, what happens is automatically this input will be selected, and this input is 1, therefore this input will be 1, and so load will be enabled and it will load whatever is the next instruction here. Got it? So in case if none of the conditions match, then that is why I want to have one more input which has to be connected to increment. Okay, so if none of them match, then automatically we have to have some hardware in place in such a way that increment will automatically happen. Got it? So if you are using the conditions, then this one will be useful to check the condition, and then depending on condition we are going to load the address, and this one will be holding what is the next address, and this one will be holding the control signals that have to be generated. Got it? Now what should be the length of this? What should be the length of this control word? So in some terminology it is also called as control word. Control word. And the memory which contains these control words is also called as control memory. This particular memory, it is different from the normal memory, control memory. And in most of the cases, control memory will be ROM. The reason is we are not going to change these micro instructions. Once it is being burnt in, we will not try to change them. So it is going to be there forever. That is how most of the computers are being built. You can even use a RAM to store this micro program, but then loading and then is a headache. So that is the reason it is better have it fixed. So most of the computers will have, or in the ROM, this control memory. Now what are the various factors, that various types of questions that will be asked is, how many bits should be reserved for condition checking, and how many bits should be reserved for this control signal, and how many bits should be reserved for the next address field. Okay, so let's try to derive that. How many bits do you think should be required here? If you have 7 flags, then we need a 8x1 multiplexer. If you have only 7 flags, why do you think that we need 8 things here? Because one of them is going to be for unconditional as well. Got it? That is the reason. So if you have 7 flags, better go with 8x1 multiplexer. If you are having a 8x1 multiplexer, in order to select one of the 8 inputs, we are supposed to have 3 bits. Therefore this part is going to be 3 bits. So this part, the condition part of the control word, is going to depend on number of flags that you wish to check for making a decision, right? If you have 16 flags, let us say if you have 15 flags, then how big it should be? You cannot use 8x1 multiplexer, you should use a 16x1 multiplexer. If you have 16 inputs for a multiplexer, how many bits are required to select one of them? 4 bits are required, therefore 4 bits here. So depending on the number of flags you have, you are going to decide this one. Simple. And how are you going to decide this one? Okay, we shall come to this later, and let's talk about this one, the next instruction. How are you going to decide about the next instruction part? The next instruction part has to point to one of the words in the control memory. Therefore the next instruction, this part, will contain the address that will point to one of the instructions in the control memory. So the size of this one will depend on the size of the control memory. If the control memory is going to have 1024 words, if the size of the control memory is 1024 words, and this next instruction has to point to one of these 1024 words, then definitely you are supposed to have 10 bits here. Got it? Therefore the size of this one depends on how many, what is the size of the memory. Size of this one depends on the number of flags. So if you have a number of flags as f, the size of this part is going to be log f base 2 seal, right? And similarly, if the size of the control memory is capital M in words, then the size of this part is going to be log capital M base 2 seal, right? And we have solved these two. Now let's discuss the size of the control signal part. Sometimes it is also called as micro operation part. So there are two ways, this particular control signals can be generated. One way I have already shown you, that one is called as horizontal micro instruction, and the other one is vertical micro instruction. Okay, so to show you the difference, you can understand it this way. See this, assume that in the previous example we had 2 registers, one is A and the other is B, and then a bus, right? So assume that in the bus, in order to select the bus, we needed 2 signals, right? So 2 control signals for the bus, and 3 control signals for A and 3 control signals for B. In horizontal microprogramming, we are going to dedicate 1 bit for every possible control input present in the system. So in this case, 3 are present here, 3 are present here, and 2 are present here, therefore 8. So 1 2 3 4 5 6 7 8. So 8 bits have to be required or have to be present in the control signal part or the micro operation part in the model where it is called as horizontal microprogramming. The alternative to this model is vertical microprogramming. In vertical microprogramming, since we have to generate 8 control signals, and in most of the cases we might not need all these control signals at the same time, we will be generating them one after the other, right? And we'll put in place the hardware required, so that even if one after the other are generated, if 2 signals are required at the same time, we will have some certain trade-offs there. Okay, certain hardwares which will be in place there. So what I mean to say is, even though we have 8 control signals totally required, I'll be having only 3 bits. So using 3 bits, I can connect these 3 bits to a decoder, and this decoder is a 3x8 decoder. So one of these 8 is going to be enabled, right? So assume that you want to increment A. Then in this case, you will have to go to the bit which will contain the signal for incrementing a, and you have to make it as 1, and you have to make all the remaining as zeros, right? In this case, what happens is, instead of connecting the bits of the micro instruction directly to the signal control inputs of the devices, we'll be sending these bits to the control inputs of the devices, right? So in this case, if this is the register A, then one of this will be connected to increment A input, right? And in order to increment A, you are supposed to give the signal in this, or you are supposed to put the word in this, such that this particular one will be enabled. Got it? So this one is called as vertical microprogramming. So why do you think that the word horizontal microprogramming is used for this and vertical microprogramming is used for this? Simple, see this. The size of the word in this case is obviously big. Therefore, the program is going to expand horizontally, or the size of the micro instruction is going to expand horizontally. But then the advantage in this one is, we'll be able to perform many control instructions, or we'll be able to generate many control signals simultaneously, which means parallelism will be more in case of horizontal microprogramming, right? But if you look at vertical microprogramming, the problem is every word will be able to generate only one control signal. Therefore, for every control signal you want to generate, you have to put a word, and so your program is going to grow vertically. Here your program is going to grow horizontally because size of the control word has increased, and here your program is going to grow vertically, right? So both are having advantages and disadvantages, both are there. So what is the advantage of this horizontal microprogramming? Parallelism can be increased, and it is faster compared to vertical microprogramming. Why is vertical microprogramming slow? Because parallelism cannot be there, and moreover, every word has to be decoded using a decoder. Here there is no need of decoder. Here everything has to go through decoder, right? Therefore, even though the size of the micro operation is smaller, the length may be higher, as well as the program is going to be the process is going to be slower. But in this case, the overall program size is going to be smaller, but the size of each word is going to be larger. Got it? So the control signals required here will depend on two things. Either you have used horizontal microprogramming or vertical microprogramming, or have you used a combination of all that. Okay, so let's see this. In case if you are using horizontal microprogramming, then what should be the size of it? The size of this one should depend on the number of control signals which are required. Let us assume that the number of control inputs required for all the elements put together is capital N, right? Therefore, the size of this control signal part is going to be capital N in case of horizontal microprogramming, right? And what if at any time we need only one out of these N control signals, which means if I go with vertical microprogramming, then anyway I'm going to use an encoder, right? A decoder, which will take this control signal part and decode it and generate only one of the signals. So in that case, I need log n base 2 in case of vertical microprogramming, right? So now if you see what is the difference between horizontal microprogramming and vertical microprogramming, one difference is clear. What is it? Control word size, right? Or the size of the control word is large. Here control word is small, right? And what about the other advantage or other point here? Parallelism is high, and here no parallelism is possible. And parallelism depends on how many bits you have. If you have n bits present in the control signal, you can pass all the n bits to be 1, and then the parallelism is n. So n control signals are generated in parallel. So degree of parallelism is very high here. Degree of parallelism is low here, right? Or no parallelism at all. Only one part can be generated. and this is faster because of two reasons. One reason is we are able to generate parallel signals, and the other reason is there is no need of decoding a instruction, micro instruction, right? And this one is slower. So what is the reason for this one being slow is you have to go through the micro instructions or control signals will be generated one after the other, as well as you have to go through the decoder at all the times, right? So these are the advantages or disadvantages for each part. In general, what we do is we'll have a hybrid system. So hybrid means we are going to use both horizontal microprogramming and vertical microprogramming together, right? So if they didn't mention anything, you always go with horizontal microprogramming. If they specifically mention that we are using vertical microprogramming, then you go with log n base 2. Otherwise, if they specify that we are using a hybrid system in which we use both the horizontal as well as vertical microprogramming, then you have to derive this separately, right? So how can you derive it? So see this one. Let us say our computer is having in such a way that we need 3 control signals in parallel at all the times. We need okay, there are, let us say, how to frame the question. I'm just trying to frame the question. See this. Assume that a computer is being designed and they are saying that there are 3 control signals and sometimes all the 3 might be required at the same time in parallel, and there are 16 control signals. Totally there are 19 control signals, and 3 of which might be required at the same time, and out of the remaining 16 at any time only one of them is required. Then try to design a best possible hybrid control word system. Are you getting this? Question is, we are having 19 control signals in total, out of which 3 control signals might have to be generated at the same time, and in the remaining 16 control signals at any time only one of them may be required. Try to compute the number of words, number of bits required in the control signal part in such a way that we use a combination of horizontal microprogramming as well as vertical microprogramming. So how to design this? See this. Now they are clearly saying that 3 are required simultaneously. Sometimes all the 3 might be required. Therefore, for these 3 control signals, you just use horizontal microprogramming, right? For these 3, which means these 3 bits will not be connected to any decoder. They will be directly connected to the units where these bits are required, where these control signals are required. And now in the remaining bits, only one of the 16 control signals are required. So dedicating 16 bits for each control signal is a waste of space. The reason is they are saying that at any time only one of them is required. So if we dedicate 16 bits, then what happens is at any time only one will be one of the control signals will be 1, and all the remaining control signals will be 0. That is the reason you try to connect this to a decoder and then let the decoder generate 16 outputs, and at any time only one of the output is going to be high, which means at any time this circuit is going to generate or raise only one control signal. So whatever you are going to place here is going to be input for this decoder. So what should be the size of this decoder? 4 by 16, right? And therefore how many bits should be here? 4 bits. Got it? So this is a combination. So till this part we are using the horizontal microprogramming, and from here to here we are using vertical microprogramming. Therefore 3 plus 4 is going to be 7, right? So if you are using hybrid, 7 are required, 7 bits are required, right? So in general, if you are having 19 control signals and there is no condition as such that 3 signals have to be always generated, and there is nothing like that, then in case of horizontal microprogramming we need 19 bits, and in case of vertical microprogramming we need I think 5 bits, So with 5 bits you will be able to generate 32 signals, but we are going to use 19 of them. And 4 bits are not enough, because if I use 4 bits only 16 signals can be generated. Got it? So 5 bits are required in case of horizontal and in case of vertical this. And under the given conditions, if I go with hybrid, then I need 7 bits, right? So what is the advantage of using hybrid? So advantage is obviously the number of bits required is going to be in between these two. It is not going to be as high as horizontal or as low as vertical, but it is going to be in these two. But what is the advantage of this? If you see this, it is going to be faster, or the parallelism has increased. The parallelism of this one depends on how many bits have we dedicated for horizontal, right? So in this case, how many maximum control signals can be generated at any time? 4 control signals can be generated. You can make all these as ones, which means 3 control signals are going to be generated from this part and 1 control signal will be generated from this part. So at any time a maximum of 4 control signals can be generated from this part, isn't it? So by using hybrid system, we will be able to increase the parallelism, reduce the size of it, right? And as well as the size of the control word is also going to be optimal, right? Parallelism is also increased, and it is not too slow and not too fast. The reason is horizontal signals are going to be faster and but this one is going to be slower. So overall performance is not going to be too slow or too fast. Understood this one? So once you see the questions, you will understand it better. Okay, so let's try to solve some questions on this, then you will understand it better. Later what happened is, okay, this is the way how the microprogrammed control, the control unit is organized. Microprogrammed control unit design, this one is called. And earlier we have already seen hardwired control unit. Now what is the difference between these two? We shall see that in one video, and then we can solve some questions on this. And later many computers recently, or even going for sophisticated computers, are going for nano programming, but I am not going to touch that part. It is not required for gate, because until recently it is not being used. So anyway that part is not going to be asked in gate, that is why I am leaving it. So nano programming is also there, nano programmed control unit, but it is an advanced concept, so we are not going to go there. Till microprogrammed is enough. Okay, so especially this control unit design is, you can think of it like this: you can do it using hardwired control unit or microprogrammed control unit. Now we shall see what is the difference between them. At the end we shall solve some questions on this. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.